Today we'll be talking about the gamma distribution. So the gamma distribution, here's the density function. So this is the PDF of what? Of gamma. So this is the PDF, the probability density function of what? Of a gamma distribution. And also it says y to the power alpha minus 1 minus e to the power negative y over beta. Then the beta alpha, then the gamma of alpha, then where that gamma of alpha is represented by this integral. So you'll just see that gamma of alpha is represented in that this interval. So we want to find the expected value of y, and also we need to find the variance of y. Those are the two things that we have to find: the expected value and the variance. So finding the expected value and the variance, we should first start with with the expected value. So number one, we can say find the expected value. So finding the expected value, there's a formula that says when you're looking for an expected value of y, you are just going to integrate from negative infinity to infinity of y of that density function dy. So we are just going to insert everything here. So remember the interval of a density function of a gamma is that from what? From 0 up until infinity of what? Of y. Then what is the density function of a gamma? It's what? It's y to the power alpha minus 1 e to the power negative y over beta. Then there's a beta alpha, there's a gamma of what? Of alpha. Then there's what? There's dy. Then what you're going to do is to take out common factor. So the common factor is just 1 over the b of alpha, the gamma of alpha. Then the integral as 0 to what? To infinity. Then powers of the same base, you add the exponent. So it's y alpha minus 1 plus 1 because we added this plus 1. Then e to the power negative y over the beta dy. Then the final what here, it's what? It's alpha y to the power alpha e to the power negative y over alpha, because minus 1 plus 1 is 0. Then there is it. There you go. So but remember, what did I say about gamma of alpha? Gamma of alpha equals to this guy here. But what exactly is this? What exactly is this guy? So I want you to remember, I want you to note that the integral from negative infinity to infinity of f of y dy is just 1 when you integrate the function from its lowest to the highest. So it means when you integrate 0 to infinity of y to the power alpha minus 1 e to the power negative y over beta over the beta of alpha, the gamma of alpha dy, you'll get what? You'll get y when you integrate this guy. Then what are we going to do? We're just going to multiply by this constant. This is the constant, you can pull it out. So this side and this side, we're going to multiply by b of alpha, the gamma of alpha. Then also this side, we're going to multiply by the b of alpha, the gamma of alpha. Then we'll be left with what? We'll be left with the integral of 0 to infinity y to the power alpha minus 1 e to the power negative y over beta dy is equals to the beta of alpha, the gamma of alpha. This is the guy. Then remember, what are we looking for? You must remember, what are we looking for? We are looking for this guy here. So looking for this guy, we are just going to do what? We are just going to say where there is alpha, we add 1. So here we are just going to say it's integral from 0 to alpha, then it's y alpha, because we added 1, it will be 0 e to the power negative y over beta dy is equals to then the beta of alpha plus 1, then the alpha of plus 1. Then this side you can simplify it and say it's alpha, this guy, and also it's alpha, the gamma of alpha. You see? Then this is the simplified version that we're going to put there. So from here we are just going to substitute this integral here on your left by that integral that we just got. So we are just going to continue with our problem. So our problem, remember our problem, it was 1 over the beta of alpha, the gamma of alpha. Then where we see that integral of negative 0 to infinity, then the y to the power alpha e to the power negative y over beta dy. This is the guy. We're just going to substitute what? We're just going to substitute this guy here. Then it means we're just going to say it's 1 over the beta of alpha, the gamma of alpha. Then we're just going to say it's the beta of alpha, the beta, the alpha, the gamma of what? Of alpha. Then remember, this guy cancels with this guy. This guy cancels with this guy. Then you are left with what? You are left with our alpha and beta. This is your what? Your expected value. So essentially you have your expected value. What do you need for for the variance? Remember, we're looking for the variance. So for the variance, remember, for the variant we need the expected value of y squared. So the expected value of y squared is just the integral from negative infinity, from 0 to infinity of what? Of y squared of y to the power alpha minus 1 e to the power negative y over beta into the beta of alpha, the gamma of alpha. This is the guy, dy. Then remember, take out the constant, the same thing here. Then leave what? 0 to infinity of y to the power alpha plus 1 e to the power negative y over beta dy. Because when you multiply powers of the same base, you add the exponent. So what exactly are we going to do? So remember, the integral here is it here. This is the guy. Then if we add 1 here, if we add so that it can be something, so we are just going to add what? We are just going to add 2 here. Where there is alpha, we add 2. So adding alpha equals to 2, we'll have y is equals to alpha plus 1 because we added 2 where there is alpha. Then e to the power negative y over beta dy of is equals to what? B, where there is alpha we add 2. Then where there is gamma we add 2. Then it means your final answer is just beta of alpha, then 2 here, then beta of squared, then alpha plus 1 of alpha of gamma of alpha. Alpha plus 1, it's alpha plus 1 alpha of gamma of alpha. This is the guy, because the gamma of 2 is just what? 1 factorial. The gamma of 3 is just 2 factorial. Is the n minus 1 factorial. So the gamma of n is like n minus 1 factorial. So we used that rule here. So we are just going to substitute this guy here. So substituting that guy here, we have what? We have that the constant, it will still be this constant. So the constant, it will be still be b of alpha, the gamma of alpha. Then here we are just going to substitute the b alpha, the b squared, then the alpha plus 1, then the alpha of gamma of alpha. This is the guy. Then cancel, then cancel. You're left with what? You're left with b, with the alpha squared, the b squared. Then you're left with this guy and this guy, which is what? Which is the alpha, which is plus the alpha of beta squared. You are left with these guys. Then after, remember, this is the expected value of y squared. Then we're just going to look for the variance. So our normal variance is just the expected value of y squared minus the expected value all squared. Then the answer will be what? Alpha beta squared. Then you're done. The final answer will be like that, because you minus that guy and this guy, it will still be the same answer, because you minus this guy of alpha squared plus alpha beta squared. Then this one, it's minus alpha squared beta squared. Then you